Today we're going to look at solving equations and inequalities that have roots in them, or radicals. One of the terms you need to be familiar with is extraneous solutions. An extraneous solution is a solution that you get from correctly solving the problem, but it does not work in the original problem. In solving radical equations and inequalities, you basically want to get the root by itself. Then you want to raise both sides to a power to undo that root. If there still happens to be another root there, then you go back and repeat the first two steps. And then once the roots are gone, you just solve it like a normal problem, but you need to make sure you check your answers because it's very, very common in solving radical equations that you end up getting answers that don't work in your original problem, extraneous solutions. So we need to get the root by itself, so we need to undo our minus 1 here to get the root by itself, so we'll add 1 to both sides. So it leaves just the root on the left side, and then we'd have 6 over here. Now that you have the root by itself, you want to end up squaring both sides because it's a square root, and you need to undo your square root. And you get this, because when you square both sides here, your squaring on the left undoes your root, and then you get 6 squared on the right. Well, then all you have to do is just go ahead and add 2 to both sides. Now this is your answer, but you need to check to see if it works. So you plug it into your original problem up here, so you replace this y with the 38. 38 minus 2 is 36. Square root of 36 is 6, minus 1 is 5, so yes, this one works. So we'll go ahead and follow the same process here. You want to get the root by itself, which in this case we have more than one root. So we're going to have the more complicated root by itself. So we're going to then have to square both sides to undo that root. And I see I'm missing a square here. So we'll square that. Well, when you square the left side, your square undoes your square root. Now on the right side, the square here, if it was all multiplication and division inside, you could apply the square to each one. But since it's not, you got to think about what does squaring mean. And squaring means multiplying it by itself. So you'd have this times itself. In other words, on the right side here, you're going to have to FOIL it out. First terms, outer terms, inner terms, last terms. Well, let's do a little bit of simplification here, combining these two roots together. Well, we still have a root, so let's go ahead and get a root by itself. So let's get rid of the x by subtracting an x from both sides. Let's get rid of this plus 4 by subtracting a 4 from both sides. Well, that's going to leave us with this over here. On the left side, that drops, and then we get a negative 16. So continue to get the root by itself by dividing both sides by a negative 4. And now we have this, our roots by itself. Then you'd want to square the right side to undo your square root, square the left side. So in other words, you get x to be 16. Now you need to go ahead and take that, plug it into your original problem, plug in 16 here, and also plug in 16 here, and that's what we're doing over here. And now you want to see if you get the same thing on each side. Well, here you would get the square root of 4, which you know is 2. Over here, you get the square, or 2 minus 4, which is negative 2. Since 2 does not equal negative 2, therefore there is no solution. So here we have a 1/3 power, but once again, remember a fractional exponent is just like a root. So you want to get that by itself by adding 3 to both sides. So you have your cube root left on the left side, a 3 on the right side. So now you want to cube both sides to undo your cube root. And so on the left side, your cubing undoes your cube root. Right side, you get 27. Subtract 1 from both sides, divide by 2, you get 13. So now you want to take 13 and plug it into your original problem up here. 2 times 13 is 26, plus 1 is 27. The cube root of 27 is 3. 3 minus 3 is 0. So yes, it does work. So let's go ahead and do this one here. You get your square root by itself, the more complicated looking one. So then you want to undo that by squaring both sides, and that's what we're doing down here. Your square here undoes your root. On the right side, since there's a plus or a minus sign in the middle here, we cannot just apply the square to each side, so we got to think about what squaring means, multiplying by itself. So then you'd have to FOIL the right side, the first terms, outer terms, inner terms, last terms. Now, let's go ahead and get this x away from that side. A little bit of simplification here. Leaves us with a 5 on the left, a 1 on the right, and then these roots combine together. So we still have a root, so you want to get your root by itself, so subtract your 1 from both sides. Get rid of your 2. Now, let's go ahead and undo your square root by squaring the right side and squaring the left side, and so we get x to be 4. Now that x is 4, we want to go ahead and plug in 4 here and plug in 4 here to see if it works. So 4 plus 5 is 9. The square root of 9 is 3. The right side, plug in your 4 here. You get negative 1 minus 2 because the square root of 4 is 2. So you get negative 3 on the right. So since 3 does not equal negative 3, therefore there is no solution to the false statement. Now let's take a look at solving an inequality. Pretty much the same process with one additional thing at the end. You want to get the root by itself, so let's subtract 4 from each side. Now we can undo our root by squaring both sides. So the squaring undoes the root on the left. On the right side we get 9. So now we can get rid of our 6 by adding 6. Get rid of the 3 by dividing by 3, and we get x to be less than or equal to 5. However, we need to be aware that we have a root here with a variable inside. And remember, we can never take the square root of a negative. So what's inside of your root right here has to be greater than or equal to 0. So I'm going to take what's inside of my root, which is my 3x minus 6. Since it can't be negative, it has to be a positive or 0. So I'm going to just take what's inside of the root, set it to be greater than or equal to 0. So all we have to do is solve that. So we're going to add 6, divide by 3. And so we get another inequality. So we get our x being greater than or equal to 2 from what's inside of the root. We get our x is less than or equal to 5 from solving our inequality. So we're looking for numbers that are smaller than 5 and greater than 2 all at the same time. In other words, you're shading in between 5 and 2. The endpoints are shaded in because it's less than or equal to or greater than or equal to. You could write that as one inequality by just going 2 is less than or equal to x is less than or equal to 5. Because you're shading in between, you want your variable in between.